Welcome to Inside Builder channel, problem solvers, Python experts, and my dear friends. Evolving missions from functional to object-oriented paradigm, featuring Turtle. As usual, we will start with the question of why. Why to move from the procedural or the functional way of coding to object-oriented? The main reason is the world is made of objects. Look around you, look at yourself. There are lots of parts of objects that make things. Whether it's your monitor, whether it's your keyboard, whether it's your laptop, the objects actually get used in the solutions. Think about the solution that the keyboard offers. Think about the solution that the paper in front of you or the pencil in front of you offers. So the object becomes part of the solutions, and the solutions are sometimes applied to the objects. For an example, you might actually apply the solution of creating code to your keyboard, and that keyboard will apply it to your processor, and your processor will apply it to some other object. So objects are everywhere, and it only makes sense to work with objects. But before we jump into the how, we have to think a little more about the data. Objects contain data. Think about it, whether it's the same keyboard, mouse, monitor, whatever objects they have some kinds of properties. They have color, they have size, they have weight, and they occupy space, they occupy the position inside the room. A lot of things they contain. These are all data, right? The solution that these objects are capable of providing and the objects themselves are different, right? So the data that it contains, the details about its own dimensions, its own location, its own properties or attributes is one part of the object, and what the objects can do is another part. The reason why I am going into explaining all this stuff is we are going to see the same kind of demarcation, a proper demarcation between the data and what the objects can do in Python coding also. Not just Python coding, any of the object-oriented programming languages that you might come across. So these are the major 3 points. The data that we are talking about can be used and can be structured using the objects. As we go forward in this series of videos where we are trying to learn problem solving from the machine perspective, we have to think in what structure the machine would like to keep the data and how easily the machines can access the data. For that, there are lots of data structures that has been created. Python, for that matter, comes with inbuilt data structures like list, dictionary, and also it has got some additional data structures which you can pull through various libraries and modules like data frames, and we have counter objects, default dicts, and many other kinds of objects can be created by ourselves. These objects that I am talking about inside the Python language or any of the computer language is made of digital numbers. They are not made of physical stuff that you see in the real world. Whether it is digital numbers or physical stuff, the demarcation that we spoke about, the demarcation between the features or the attributes of a particular object and what the object can do is still there. So we will be seeing this in action. Next comes the question of how. So before we actually start implementing, we need to think how we can create objects inside a programming language. It's a straightforward process if you look at it. Once you understand how the objects and properties and methods are created inside the programming language, but before that it is literally impossible to understand. It becomes very tough to visualize what exactly happens. So my objective in this video is to make it as easy as possible for you to not just visualize how the objects are created and how they are manipulated inside your processor or your computer, and how you can actually create more objects, more new objects of your own making. That is the primary objective. So the objects that we are going to implement should have properties and attributes. That's the first thing. That is the data that we are talking about. And the second thing, the object must have characteristics and abilities. So these are the two things. So when we are going to say how we have to have these things, we have to somehow build these things into the objects that we are going to create using the code. But what? So once you answer these what an object contains, what an object must contain inside the programming language, then the things about how becomes way more easier. So an object has to contain itself. First thing, that is the main important point. An object must contain itself, meaning it should contain its own blueprint. That is the first step. Second, it has to contain the attributes or the features that the object is possessing. Also, it has to contain the methods or the capabilities or the abilities in form of methods to operate on its own as well as on other objects. And finally, there are certain special methods that are by default defined in the programming languages itself. So it has to inherit those methods and those variables when we create an object inside the programming language. These are the four crucial aspects that you have to understand. At this moment, all this English that I'm talking about, English explanation I'm giving might not be very helpful. However, as we drop down into the visualization part, then this is all going to make sense. How we are going to move forward is turtle module. So this is one of the inbuilt module in Python language, which is called as turtle.py. And we'll be using that to visualize how Python language creates objects and gives its ability. And in order to make this possible, what we are going to do is we are first of all going to explore the capabilities of turtle module in this video. And following that, we are going to create a rectangle. Actually, we are going to build a rectangle procedurally by typing code using turtle module. It all starts with the basic steps, right? So you have to first of all do yourself what you want the machine to do. And once you have done it multiple times, then you can see that which part of the activity can be repeated and can be clubbed together, can be called as a function. Then you can let the machine know that, okay, I'm going to make this as a function. That is how we are going to build it right now. Let's now jump into turtle module. So I have the command prompt here, and I'll be using a different IDLE for working on turtle module. It is called as Ipython. In your machine, if you are unable to get this Ipython application, then I would suggest to do a pip install Ipython. That is all it requires to get this particular IDLE. You will be able to get that. After that, do execute this command, and you will be dropped into the Ipython IDLE. This Ipython IDLE will be different to the regular Python IDLE, and it has a couple of tricks in its back. That's why I'm using this here. This is an enhanced interactive Python. So that is the point. It's called as Ipython. It is interactive Python, and it has got these green and red. So if I'm going to say import, and you can see it tries to autofill. So I'm going to say import turtle, and it says it is autofilling because I've already typed these commands in this particular IDLE and it remembers. So this is one of the first tricks that I wanted to share. Second, you can see that each and every command that we are executing, it is numbered. This is one of the easiest way to discuss when we are working on this kinds of video setup, or you are in a meeting or something. You can tell that which command you are referring by referring to the number. Second, what I'm going to do is I'm going to press Ctrl L. So once I press Ctrl L, it will clear the screen. If you do this Ctrl L in your regular Python, it will not clear the screen. In case of regular Python, you have to import OS, and after import OS, you have to do os.system.cls to clear the screen. And the regular Python will return the value called as 0. So once the screen has been cleared successfully, then there is a return code of 0, and there is something called as out. So this out is the result that the command provides or the execution provides. This is a brief about Ipython. but we are here to learn about turtle, right? We are here to learn about how to get turtle to build a rectangle and procedurally. That is what we are going to discuss in this video. Let's now create a turtle. So in order to create a turtle, you have to say t is equal to t dot turtle. And once I press t dot capital T and I press tab key, what happens? It opens up this supporting menu inside the IDLE. So this is one of the important point I want you guys to use most often. So now if I create the turtle, I have to give the shape of the turtle. So shape of the turtle is turtle, and I'm going to press enter. And it will take a moment. After that, you will see that it will open a separate window on your system, and you'll see that Python turtle graphics title coming up. I'm going to modify the screen right now. You can see both the terminal as well as the turtle movements right now. We are going to see a couple of capabilities of the turtle. First, we are going to say turtle forward. So we are going to ask the turtle to move forward by 100. So this is first method that we are going to do. And once I executed turtle dot forward, so this is a method. This is not a function. So this is a method that is connected with this t object or t instance of turtle. How will I know that t is a turtle? You have to just say type and say t, and you will see that it is of type turtle. Next, we have made it to move forward, and when we try to make it move forward, we saw it is drawing a line. How is this happening? This is happening because the turtle is attached with the pen, which can write based on the color that you have chosen. So if I say turtle dot pen, you can see that you can actually change the pen color. So if I say pen color is going to be red, what will happen is, now once I make it to move forward, it will be red in color. So if I say turtle forward, you'll see that it is red in color. It's not visible here, but in order to make it visible, what I'm going to do is I'm going to increase the pen size. So I'm going to say pen. You can see that there is a pen size here. I'm going to say 10. Okay. And apart from this, before I make it move forward, because it might actually go out of the screen, I'm going to rotate the turtle. For rotating, there are two options. There is right and there is left. And to these methods, all these are methods: pen size, forward, pen color, all these are methods. And right can be called using right word itself or RT. So you can do any of one thing, and you have to give the degree by which the turtle has to turn. So I'm going to say I want the turtle to turn by 90 degree, and it will turn clockwise. So when you say right, it is going to turn on the right side. When you say left, it is going to turn on the anti-clockwise. So let me show you. I'm going to execute this. You saw that it turned clockwise and it started showing down. Now let us make it to move forward by 100. You saw that this line is thin while this line is thick because we increase the pen size. Next, we are going to continue. So we are actually drawing the rectangle right now, right there, right? So what we have to do now is we want to make the turtle to move towards left. So we want it to move towards left. So for that, we have to make the turtle to turn by 90 degrees and start looking this direction towards left. So I'm going to say again T right and 90. You'll see that it has turned to right. Next, I'm going to ask it to move forward by 200 because we actually made it to move forward by 2 times 100. You saw that here, right? I'm going to make it to move 200 times and it comes to 200. Next is called as home. So if I do a home, what will turtle do is it will go back to home and it will change its position to the starting state. So let me execute this. You see it went to the home, it turned itself and it started looking at this side. So we have our rectangle. This line looks thin. So what I'm going to do is I'm going to make it again move forward by 200. And now I have filled the rectangle with green color. There are a lot more things that you can do with Turtle. One of the important step I want to mention about this step is this series of steps is that whatever we did here, all these things you can copy into a script. You can copy this into a script, and if you execute it, the same thing will happen. For that, I'm going to show you an example. So let us go back to the presentation. Right now, we have explored the capabilities of Turtle module, and at the same time, we have procedurally built a rectangle. Now we have to build the rectangle again using a script, because at the end of the day, whatever we did in this command prompt, whatever we did in this command prompt will be lost once we exit it. So if I say exit, what will happen is the command prompt will exit, the Ipython ideally will exit, and the screen also will exit. The Python screen, the rectangle, the canvas that was containing the rectangle also will exit. So all this is lost. In order to get these instructions into a script and to test it out, we are going to write all these things into a script. So I am going to copy it, all these things, including the import process. Okay, the import process is not here. So I'm going to copy all these things. I have already copied it, and I am going to create a new file, new Python file. So this is going to be a Python file, and I'm going to name it as, and I'm going to place it in procedural rectangle. So I'm going to call this as procedural rectangle. Once I do that, first thing is you have to import Turtle. In case of, let me zoom in a little more. In case of VS Code also, the auto completion occurs. So that is one of the good things. I am saying import Turtle. There are lots of Turtle demo also. So you can look at the Turtle demo. So that is one of the things that I wanted to mention. So what I can do is we can say Python M, and the module name is Turtle demo, and we can call the demo. So if I say Penrose, so this is one of the demos that is pretty interesting to watch. You'll see that it keeps on building this darts and kites. So it keeps on building and it fills the entire screen, and it keeps on repeating, so it doesn't stop until you close it. So Turtle works on something called as a loop. It's called as a main loop. Once you call it, it will do the same thing again and again and again until you click and escape it. So this is another one thing. These are all happening because of the background functions that has been already written using the concepts of loops and using the logic. All these things have been already accomplished and it has been given to us. So this is a demo that you can watch. And also there is one more demo that I like the most. That is the we have let me go here. I can actually show you that also. If you do Turtle demo and dot, you will see various kinds of examples that is already available. These are the examples that is present. So if I say if I want to look at the Lindenmayer, so this is one of the demo that I wanted to show you. Lindenmayer. This is the Lindenmayer pattern that is getting created, and a turtle is actually drawing it, and you see that the turtle is not visible. So we can hide the turtle also. You can actually look at these code inside your editor. I'll be showing you how to do that in a couple of minutes. So these are some examples. I want you to look at it, and you can get some clarity on what is possible with Turtle. Now let us proceed with our procedural building of rectangle, and I am going to bring all the commands that we had just now written. So what I'm going to do is I have copied everything and I have brought all the commands here from the beginning to the end. So you can see the command numbers, all these things. So I'm going to remove the command numbers because we don't need them, but rest of the things we have to keep. And here we have seen that we moved the turtle by forward one time. We checked the turtle type. We don't need this. So this is the output that we got. We changed the turtle pen color to red. We made it to move forward again by 100. So we can remove this and we can do like this. We can actually move this here. So we change the pen size, we increase the pen size to 10, and then we make it to move forward. Why we are doing this? Because we want it to be a uniform 200 uniform red color thick border rectangle. And then we are asking it to move by, we are asking it the turtle to turn by 90 degrees, and then we are asking it to move by 100, right? And then we are asking it to turn by 90 degrees, and then we are asking it to move by forward by 200. So we are asking it to come back, and then we are asking the turtle to return back to the home, and then we did a forward, which is not required here because that was the final step that we did to close and make the border similar, right? And after this it is done, right? We can say print done. We can say print done. Sorry about that. There is one more option also. We can actually call turtle dot text. Just a minute. Okay, we can just say print done. And one more important point I wanted to mention here is that I'm going to, there is one mistake here. So you see that I am using t.turtle, not turtle.turtle. So I have to change this import turtle as t. So this is one of the importing processes that we need to follow in order to make this work, or else it will error out. If you guys are new to Python and if you want to understand how these importing works and how the functions are getting imported from there, because all this, the turtle that you see here is coming from the module called as turtle, and this module is actually a file. So if you click, if you click on this turtle word inside the VS Code, this works in VS Code only. So you can see that it is telling it is module turtle, and it provides the details of what this turtle is capable of and what you can do, and it gives a basic description. Once you click on this and if you press F12 on your keyboard, it will open up the module itself. So this is the entire module of turtle, which is already present in your system. So it is present in D. In my case, I have installed Python in D, and inside that there is library, and inside the library you have this turtle.py. You can visit there, and you can also look at the various other libraries that you installed, and like this you can view the files there also. The reason why I'm showing you this turtle right now is we will be using this in the next step, where we are going to create functions as well as object-oriented turtle. Let's go back to the procedural rectangle. So we have already built the procedural steps that we want, and hopefully we will be able to build the rectangle. Hope is not something we should use in computer coding. We should know the logic, whether it will work or not. So let us see what happens. I'm going to execute this right now. So I can execute it inside VS Code, or I can execute it in the command prompt. Both are okay. I'm going to go to Python. All this code that you see here will be present in the GitHub repo, the Python DE learners data GitHub repo, inside the scripts folder, and I can say Python procedural rectangle, and once I execute this, you'll see, sorry about that, the issue is the display that is going to build the rectangle is in the another one display. So I have to pull it here, so which is going to take time, and by the time it comes to the line number 13, the loop completes. So for avoiding these loop completes and the display closes, To avoid that, what we can do is we can actually create something called as a main loop. We can import the main loop also. We can use the main loop also. For that, I'm going to use the if name is equal to main. I'm going to execute this as a proper Python script by checking its name, and in the earlier video I discussed why I am using this if function, if checking there. So you can take a look at the earlier video. If you scroll down here, I can call t.main loop. What will happen is this main loop will keep on running and it will not close the window. So that will help me out in showing you once a rectangle is created. So this t.main loop will help me, and I'm going to save this again. I'm going to bring this a bit down, and also one more thing that I'm going to do is I'm going to create an input here. So temp is equal to input. So this input is going to hold the execution till I press the enter key. So what I'm going to do is I'm going to say press enter when ready. So in this way you can control what is happening procedurally, right? So let us save this, and then we are going to execute it. So you see that I have the graphics here which is going to work, and it is saying press enter when ready. So what I'm going to do is I am not going to press enter still. I'm going to first of all set up the screen so that you guys can see what is happening, and then I'm going to press enter. Once I press enter, you saw the entire turtle got created, and then in the main loop it actually broke because this main loop is not inside the turtle. So I had created a turtle here, so that is a mistake. The same name I had provided here, so I need to give a different name here because the module also has been imported as t, and the turtle variable name also I have given it as t. So I need to change it as t1. So what I'm going to do is I'm going to do the modification and get back. So now I have modified it, and I'm going to execute this again. You'll see that the window has been created here, and I'm going to, it is asking me to press enter when ready. It is going to press enter, and now it is going to wait. So the window is not closing like as we done already, and here the done has come. Now we can close this, and once we close this script will come out. So in this brief discussion, we have seen certain capabilities of turtle, not all the capabilities of turtle. We also saw how we can build the rectangle procedurally. We saw that, and we then moved from command prompt to a script, and we executed the steps procedurally, and then we saw how the rectangle was built by turtle. All these things we saw, and one thing that we were facing challenge is that if we have to modify the size of the rectangle, what you have to do is we have to modify this number twice, we have to modify this number, and if you want to modify the color, then again we have to do it manually, and we have to do it every time the script is run. Probably you can get a input and modify these forward and upward, I mean the length and breadth of the rectangle. That is one way. However, what if we want to create multiple types of rectangle, and we want to give or what we want to create a list of rectangles, and we want to build it one after the other. All these things are possible because rectangle is an object, and as you saw, rectangle contains the length and the breadth. It has got a color on the border, and on rectangle we can do certain operations. First and foremost operation is we can draw it, right? So that is itself an operation. So we will see in the next video how to create, first of all, a function based on these same instructions, how to create a function, and then we will move forward and create an object, a rectangle object which can draw itself. So stay tuned for the next video. Till the next video, as usual, you have to practice on these procedural building of rectangles. If you want to work on circles, triangles, circle is already there inside turtle, so you don't need to build it, it's already inbuilt. You can work on trying to bring some new shapes, as I showed in the demo. You can try to work with different shapes and see whether you can do it procedurally and then do it using a script. So these are the things that you can try with turtle. With that said, I would like to leave with 4 words, that is practice, 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 practice. See you guys, have a great time.